In today's episode, John is joined by Professor Christopher Consolis. Professor Consolis is the Professor of Astrophysics at Nottingham University. Previously, he spent 4 years as a National Science Foundation Fellow at Caltech. He studies the formation of galaxies, addressing the issue of how and when galaxies form by examining the detailed properties and characteristics of nearby and distant galaxies. He was also the leader of several large extragalactic surveys using the near-infrared part of the spectrum, including the GOODS Near-Infrared Survey, the largest Hubble Space Telescope program ever led outside the US.
Chris Consolis, welcome to the program.
Thank you very much.
Now, Chris, you have a paper out that the media ran with, of course, and the headlines were that there, are 36 alien civilizations in the Milky Way, which is, of course, mischaracterizing it. In reality, it's just a low-end estimate, a stab in the dark based on the scant bit of information that we have based on our solar. But a lot of it seems to depend on the strong and the weak Copernican principle within astrobiology. Could you give us an overview of what those are?
Yeah, sure, no problem. So, essentially, the idea is that we are not unique in the universe, in the sense that if you have the right conditions to form life in the same way that we have, then you will form life. So that's basically the underlying assumption to both principles, the Copernican astrobiological, weak and strong. The difference is essentially due to time scale. So the strong principle is essentially that life forms exactly the same way that we did. So life could form in many different ways. There's no question that it's possible. We don't know. First of all, we don't know how life forms. We don't know if it even forms anywhere else in the universe. But we can start making assumptions and start seeing what those assumptions lead to. And if one day, when we actually do know something about intelligent life in the universe, in our galaxy at least, then we can compare with these assumptions and see if our assumptions make sense. So that's kind of the whole philosophy behind this. So the strong principle is essentially that life, intelligent life, communicating intelligent life, like we have on Earth now, will form around a star which is similar to our own star, the sun, and in which a planet is in the habitable zone, which means that it's not too far away from that star and not too close, such that the temperature is not too hot nor too cold, just like we have on Earth. And you're allowing that star and planet to exist without disturbance for about 5 billion years. And the strong principle says, at that time, just like on Earth, you will have formed life and you will have formed intelligent communicating life. So that's the assumption that we make. So the other one is the weak principle, which says, okay, maybe it doesn't happen in 5 billion years, right? And that's certainly possible, but it needs at least 5 billion years, such that it could happen in 6 billion years, 7 billion years, 8 billion, you get the idea. So it's sometime after 5, but you need at least 5, because that's how much we have had, more or less, maybe a bit shorter than that, but about 5 billion years to form intelligent communicating life. So under those two assumptions, you can then use the other information that we know about stars in our galaxy, about planets around those stars, about the abundance of elements in those stars, like how much carbon, nitrogen, oxygen that you have in those stars, and therefore also around its planets that you need to form life. So by putting all that together, we're able to get these numbers. And in our paper, we go through this in great detail, including the 36 that you mentioned. And that number is essentially looking at the strong principle, where you have the assumption that life forms exactly the same way it has on Earth, with a similar metallicity, which basically just means anything heavier, any elements heavier than helium, the content of that around your star or in your star. That's how you get to 36. And there's, of course, an error on that, which we can talk about. But that's basically the difference between the two Copernican principles.
What's the error?
So for the 36, the error essentially goes down to only a few, about 2 to about 200. So that's really the range that we get. But 36 was the central location of the most probable number. But it's certainly not necessarily the correct number. It's just what you would expect as the central number. And there's a range of values which go from 2 to about 200.
Now, one question about this is the time. Is this at any given time, or is this across a certain amount of time?
This number is how many exist at this moment now. So this is how many exist today. So if you were to ask how many existed in the past, you actually would find that there's more. And the reason for that is simply because if you look at the star formation history of our galaxy, we're actually in a decline. The star formation rate has been going down. That is how much new stars you form per year on average has been going down for the last about 8 billion years. So if you need 5 billion years to form life, then the peak star formation was about 8 billion years ago. So the peak time for forming life under the strong principle would have been about 3 billion years ago. And if the lifetime of those civilizations is short, and by short I mean anything like a couple 100 million years, which is not very short, but in terms of cosmic time, that's actually not very long. So even if those civilizations lasted for millions, hundreds of millions of years, they would be gone now. So we wouldn't necessarily be able to detect them because they would no longer be communicating their signals out into space.
So we may be on the back end
That's right.
of the formation of life in the Milky Way, and that most of the civilizations have already come before us. But there's still maybe, tens to hundreds of civilizations, depending on which principle we use, present right now that we could detect. And that gets into communicating
Yeah.
intelligent civilizations. So you're assuming that they're actually communicating, at least in a form that we can recognize, like radio.
Exactly. So this is a communicating intelligence. So essentially, you're not going to be able to detect anything on a planet that's intelligent life unless they're somehow communicating their existence. You can find life on other planets by looking for, say, an unequilibrium in the atmosphere of elements, or look for like chloroform in the atmosphere through spectroscopy of planets. People are very, very much actively doing that, and I suspect that probably we'll find some kind of primitive life based on other planets using that kind of technique probably in the next decade or so. But finding intelligent life is a whole different thing. So you need to have some evidence that there's intelligent life, not just life. And so you need signals that's made by an intelligence, that's a conscious being, which is sending something into space, which is not something that can form in a naturalistic way, like something that we know from astrophysics, like a signal from a pulsar or from normal stars, flares, that kind of thing, which there is a variable universe out there. Many things do change in time, but we can predict it and we can understand it, where it comes from. But we're looking for intelligent life. You have to find things which can't be explained by known astrophysical quantities, and even in a signal that has some kind of intelligence in it. And there's many, of course, in science fiction, you hear about many different ways that that's been done, like listing like the value of pi or something like that. And that really is what you would need to do. So you have to transmit things into space. That's the key thing. So we've only really been doing that for about 100 years. So that's part of our whole assumption here, is that we make as a lower limit the lifetime of these civilizations is 100 years, because that's how long we've been around. So we don't know how long the average lifetime of a civilization will last. It could be 100, it could be 200, it could be a million. We really don't know. So we go into great depth about those numbers as well. But by using 100 is how you get this 36. So in many ways, it's a lower limit under our assumption that life forms in a very similar way. An intelligent life and a communicating intelligent life will form in a very similar ways as it has within our own solar system.
Now, about the assumption on how long a civilization lasts, how do you derive that?
Well, we use the only system we know, which is the Earth. And if you want to believe that, or if you have an optimism that we will last for millions of years, then you can easily plug that into our equations and come up with a number of civilizations. But since we only know that we've been able to communicate for 100 years, we know that we have lasted at least that long. So we take that as our lower limit. And we're not saying that, we're going to destroy ourselves now or any time in the near future, but we don't know for sure how long we'll last. But we do know for sure that we've lasted 100 years communicating our signals into space. So that's what we use within our value. And in many ways, that is the lower limit. So there probably would be more, depending on how long our civilization might last. It's really the key factor in all of this.
Now, how would it affect it? Because I sort of expect the same that you do, that in coming years we're going to see exoplanets and we're going to see weird oxygen levels and carbon dioxide levels as a biosignature. And if we see these and we see them commonly, does that increase the odds?
I think it does, but in terms of our calculation, it doesn't really. It still would be the same, because we actually discussed this on our paper as well. We would expect primitive life, like plants or something like that, to be very common, just based on the way that we're making these assumptions. So we would expect that very many planets would have very primitive life on them. So in this sense, it would give us optimism, of course, to say, well, look, life can definitely form on other planets. So in that sense, yes, so it validates some of our assumption, which is that life will form on other planets if the right conditions are there. But that doesn't mean necessarily intelligent life or communicating intelligent life. So those are the other assumptions that we make. But it would at least give us part of the assumption that we make some validity, in the sense that at least primitive life is forming, and that can perhaps be argued to lead to intelligent life eventually.
One thing about Earth is that it is possible for it to have formed intelligence earlier than it did, right? In other words, if say the dinosaurs hadn't been reset, or something like that, we might have had life in this intelligent life on this planet earlier.
Yes, that's certainly true. But the thing about this is you have to realize the dinosaurs were around, some millions of years ago, right? So in terms of looking at the lifetime of our sun and when intelligent life formed, we're talking about 5 billion years, a couple millions of years. It doesn't make any difference at all. So in that sense, it's definitely within, say, the noise or the errors in terms of when that life actually developed. We really haven't been around, and even, let's say, life, which is not basic on Earth, has not been around for very long. So it still fits within this picture. Even if you form intelligent life in the dinosaurs, it still would be the same number, about 4.5 billion years to 5 billion years.
More or less, but within that is something sort of scary, that life was microbial on Earth for a very, very long time before it started really going places.
Absolutely.
And that makes one wonder if that's the great filter, is that there's life in the universe everywhere. It's just mostly microbial, which would lead to
is very likely
a very low number.
Yeah.
I would think I think that's it. I think when we talk about great filters and Fermi paradox and things like that, I think that's a really strong one, that eukaryotic leap happened at all.
Yeah, it's really an interesting question, and I'm not an expert at this, but it's evolutionary pressures to have a life evolve in the way that it did, so that species could survive better and take advantage of their environment. So who knows that over a few billion years that kind of a transition wouldn't just happen at some point. It's possible.
Now let's talk about distances. So with this work, with this number 36 or thereabouts,
right?
How far away could one guesstimate the nearest alien civilization would be?
Right. So this is part of the interesting aspect of all of this, and this is not something that we went into in much depth in the paper, but we did a little bit. If there's 36, then the nearest one would be roughly about 17,000 light years away. But that's under the assumption that these civilizations only last for about 100 years. So let's say that we see a signal coming from that civilization. It would have taken 17,000 years to get to us, just because the speed of light is constant and is not infinite. So it takes that long with that light signal, whatever it is, radio waves, to get to us. So by the time we receive it, 17,000 years after it's left that planet, that civilization would be long gone. Even if it's a couple hundred years of a lifetime of the civilization, it would certainly be long gone. So if we were to answer that, send out a signal saying, hi, we've seen you, we come in peace, or whatever, and send it back to them, it would take then 17,000 years. And then, presumably, if anything was left, which in our scenario there would not necessarily be, it would take 17,000 years for them to send a signal back. So assuming that they somehow beat the odds and survive for a very long time, that it would take 34,000 years for us to be able to send a message and get an answer. So it's kind of a sobering thought.
So how do you arrive at that proposition?
Arrive at the 17,000?
Yes.
17. So it's basically just taking the 36 number that we calculated and looking at the volume of the Milky Way, looking at the stellar distribution in the Milky Way, and just evenly distribute those 36 throughout the Milky Way, and then you just calculate what would be the closest 1 to us based on that distribution. So it's a random distribution of the 36.
I see. Now, how do you? What assumptions are you making regarding the lifetime of these civilizations deriving the number?
So for that case, it's the same as ours. So it's civilizations that have been around for 100 years. So this is one of the cool things about the paper, is that if you actually start doing SETI and find things and find civilizations transmitting signals that are intelligent and they're relatively nearby, and you find there's more than, let's say, a couple, so that it's statistically significant, then it's a very good sign that the average lifetime of a intelligent communicating civilization is much longer than 100 years, because otherwise you would not expect to find so many nearby. So in many ways, by looking out with SETI and trying to find other intelligent communicating civilizations throughout the galaxy, we're actually learning about how long we may last as a civilization on Earth. And if we find nothing throughout the whole galaxy, if we search and find nothing at all, then it really doesn't look good for our long-term survival, unless, of course, this is the other option, that we're actually really unique and that our existence is just a random fluke. Or if you're religious, maybe you can believe that there's some religious answer for how we've existed on Earth. But either way, it has very deep implications for science and for just our existence in general, by looking and understanding how many other civilizations do exist throughout our galaxy today.
And it has to be said, though, that science in general does not like uniqueness. One-offs are not something that we usually see. We want predictability and we want to see other examples. And we pretty much see that in everything, so why not life, right?
Absolutely. You think just like I do. So this is exactly how I think as well. So if you have, for example, a gas cloud that has the right temperature, the right mass, the right density, it'll form a star or a galaxy depending on how big it is. And it always does. It doesn't just randomly happen, right? It does. So, and in chemistry and even in biology, if you do an experiment with the right conditions, you get the same outcome. This is the whole idea of science. So why should humans well, let's not say humans, but why would intelligence in a living, conscious, existing creature, why should that be outside the realm of science? So if you have the right conditions and the right amount of time, why not also assume that you would form similar things as what we are in terms of our intelligence? And this is how I like to look at things. And so it could be wrong. I completely admit that this assumption could be off, that we could indeed be extremely unique and rare. But I would argue that is actually quite interesting to know as well, and that by knowing how many we should expect, which is what we're calculating in our paper, and by doing a search, which will take a very long time. So this is a search for every star in our galaxy to see if there's intelligent life will take much longer than our lifetime. It won't happen anytime soon, but one day it will happen, and we'll know, and then we can actually know something more about where we're going and where we came from, which is essentially what all humans really kind of want to know about. And this is another way of getting at those answers.
It's kind of interesting. Regarding anything within astrobiology, we make a lot of assumptions, and I think it's interesting that one assumption we make is that it's going to be around a sun-like star or around a star at all. And I often wonder if that maybe advanced alien civilizations, say they do have a very long existence, might they better communicate say, older stars like that? So do you think are we thinking too much like humans and not enough like aliens?
Oh, I think that's definitely the case. It's very hard to imagine what another civilization that's intelligent might look like, or what they might do. But I think we can make some kind of guesses about what might happen. So another thing, which is interesting to think about, is that if you have, let's say, a very advanced intelligence throughout the galaxy, let's say you have one particular civilization which is super advanced and has had an advanced civilization for, let's say a couple million years. right? So we've had, a technical civilization for maybe a couple hundred years, and we've done a lot, right? I think nobody would question that. We've gone from, even the last 100 years, we've gone from like, horse and buggy to, well, maybe not horse and buggy, but close to that, to having like, super fancy artificial intelligence and all kinds of technology, which is just incredible. So imagine if we survived for another million or a couple million years, what kind of technology, what kind of things we might be able to do. It's unimaginable. And so, and in some sense, thinking about that is similar, I think, thinking about what these other intelligence might be doing if they existed for a very long period of time. But one thing that I think might happen, and one reason why I think that intelligent life in our galaxy is pretty rare, is that it's probably the case that other intelligence in our galaxy would perhaps be able to destroy themselves just like we can. So if you have a technology which can transmit into space, you probably have the kind of technology which you can use to make atomic weapons, to do to have a greenhouse effect with burning the equivalent of fossil fuels, which probably exists in some form on other planets as well. And that is something that we still don't know about in terms of our own civilization, whether or not we can overcome those problems to survive for the long period of time. But even if you do eventually destroy yourself, if you are a intelligent species on another planet, what you might be able to do is, first of all, you might be able to send off colonies to other planets, other stars, and they obviously would not necessarily be destroyed by any kind of, self-destruction, which happens on, say, the original planet they come from. I know this is going to sound very science fiction, so I apologize a little bit for that. But you have to think about these things in a more general sense, I think. But the other idea is that perhaps they also, if they're super technologically advanced, they could do things like invent let's say, a machine kind of technology which colonizes the galaxy without any kind of, it's called biological presence of the intelligence which evolved from more primitive life, which we have to assume is how they formed, like we did. But if they could invent like robots that could go around the galaxy and could fix themselves, could somehow build other robots using materials on other planets, then even if they destroy themselves, that kind of super advanced technology, which isn't so far fetched from what we can do now, right? I mean, we probably could do something like that if you had enough money and a bit of time. You could probably do something similar. Maybe not take over the galaxy, but you could have something going throughout the solar system. We already sent things to the outer planets and even outside of our own solar system, and those things are many decades old. So imagine if we wanted to do something now, what we could do. So it's not unimaginable that even if they survive for thousands of years as a technical civilization, that they could build something like that. And that would be independent of, say, the drives which make an evolved species that's intelligent like ours, which we evolved through natural selection. Therefore, we have tendencies to be, let's say, a bit selfish and violent, which I think I can agree that humans have a tendency to be, at least on a large scale. So if you can build machines which avoid that problem, then they could potentially survive for very long periods of time without having to worry about this self-destruction. And we might have seen that, and I think we probably would have by now. But maybe they have a way of hiding themselves, or maybe we just don't know we've seen it, or maybe it's just too hard to see. But you could imagine that kind of, let's say, result of intelligence can survive for millions, tens of millions of years, who knows, for a very long period of time. And within that, we can really do quite a lot. And we don't really see that. And I think this comes a little bit into the Fermi paradox. But yeah, I think that is a possible scenario which we don't see. So that I think gives us an idea that the lifetime of civilizations is either too short, or that life doesn't form. This assumption is wrong, that life doesn't form in the same way it does on Earth, on other similar type planets.
Now let's go into that. So evolution is machine civilization could have lots of biological, especially if they thought in absolute terms. Well, actually,
Right.
So, but we right. See this. We don't see a we haven't even seen any evidence of
Right.
So it seems pretty clear that nothing's ever come through here in my series or something like that, which you would think would happen if the von Neumann probe idea were correct. You'd think we'd see evidence, but we don't.
Yep.
So you're saying that suggests that biological civilizations just don't get that far, and they're gone before they reach that, right?
Yeah, I mean that would be my sobering, sort of depressive thought, because it is depressing to think that is true. You know, if civilizations did exist billions of years ago in our galaxy, which they could very well have, that they're just gone now, and that they've left no kind of remnant beyond their own sort of local solar system, let's say, just because they weren't able to make these machines or survive on their own for longer than that. I hope I'm wrong, because it would be very exciting to know that there's something out there, but we don't really see it. So, as I said, maybe we're just not looking the right way, which hopefully that's what's going on. But it doesn't look good, let's say, at this moment.
Or it could be situational, that you do become a machine civilization, but very efficient.
Sure.
Or something like that. And that, these ideas show civilizations error, but they actually become very discreet. Maybe in some of the coldest areas of the galaxy, they can find better computation.
Yeah. I mean, it's fun to think about these things. That's certainly possible.
Now, you've also worked in another interesting field, estimating the number of galaxies in the universe.
Yep.
Number one, is that within the observable universe, or do
Yeah,
you
good question.
jump even further out from that? And what numbers did you arrive at?
This is another fun thing I did a few years ago. So, the universe, what is the universe, right? So the universe is defined in so many different ways. So I'll give you the answer quickly, then I'll explain the implications of the answer. The answer to your question is that it's the observable universe, and it's the number of galaxies that it's not the number we can see now. It's the number that do exist, that we know are there, but some of them we can't see. But what we have in our universe is a horizon, and the horizon is basically as big as how long or how far the speed of light's been able to travel for as long as the universe has existed. So we're only really seeing sort of a fraction, say, of the universe, because we can only see as far as, say, this, in a basic sense, the speed of light times the age of the universe. We can't see further than that because the speed of light isn't infinite, so we're not seeing the very edge of, say, the real universe. We're only seeing things back to when the universe began, in a sense, in our own local volume. So there are definitely galaxies beyond our horizon, which we can't see, and which we won't be able to ever see. I mean, if you want to wait a couple billion years, you'll see more, but you'll never see them all, just the way it is. And so there's certainly more than that. But the answer, the number we get, is about 2 trillion. It is the total number that we could see in our own universe. And the number before that calculation was a couple hundred billion. So it effectively went up by a factor of 10 based on a calculation that we did using very deep Hubble Space Telescope imaging. So this result is based on empirical observations, but looking at it in a way and answering how many galaxies we know are there, but we just can't count them exactly, but we know that they are definitely there. And then just adding them all up, and we get this 2 trillion number.
Which has a very, very serious implication on our conversation, because 2 trillion galaxies, all containing billions of stars.
Yep.
We can't possibly be alone in this universe. I mean, those kinds of numbers, if we were alone, that immediately takes us right into...
Yeah, I completely agree. In fact, if you ask me, where I think advanced civilization might be, it's probably not in our own galaxy, but it's probably in another galaxy, somewhere in our universe, maybe not too far away from us. But if you have 2 trillion galaxies to search for, yeah, I agree with you completely. It'd be incredibly unbelievable that we were the only one with all of those stars and galaxies throughout the universe. It's just unimaginable that we would be the only one.
And one wonders if life is localized to a galaxy necessarily, because there are a lot of stars floating around in between the galaxies. So do you necessarily even Is that even possible?
Oh yeah, I think that's so that could happen. The probability is lower simply because most stars are in galaxies. So you have stars in between galaxies, and for example, in clusters of galaxies, you have a lot of diffuse light which is not attached to any one galaxy, and that light though is generally, and those kind of stars are generally not a big fraction of the total number of stars in the universe. Most stars are found in galaxies, so it's certainly possible that some of those stars could host life. There's no reason why they couldn't.
Would make for incredibly boring astronomy, though. If you were a scientist and all you could see is distant galaxies, and you wouldn't really be able to do a whole lot more. But that's still better than being a scientist on a planet that reaches intelligence closer to the end of the universe, where you can't even see anything, where you can't really do very much cosmology at all because you just can't see anything, other than maybe a close red dwarf or something like that.
Well, sorry.
Go ahead.
Yeah.
Go ahead.
The problem with looking at distant galaxies is that you're actually looking at them when they're very young as well. So that makes the problem even worse, because we can see galaxies back to when the universe was 500 million years old, and that's a small fraction of the age of the universe. So it's very unlikely that those galaxies form life, because there's simply not enough time. We're going to use this 5 billion years sort of evolution needed to form intelligent life. Those galaxies would not necessarily have life, simply because they're just too young. So the more nearby galaxies are more evolved. But again, if you need 5 billion years after the Big Bang, you could have had something, and that's still very far away. I mean, it's like 8-9 billion light years away, so to speak. So that's very distant. Over half of the universe. Plenty of galaxies between us and that period of time.
Now, what else are you working on?
So, in terms of this search for, say, communicating civilizations, I actually have a project I did with some undergraduate students to look for this in external galaxies. So it's sort of a real search for SETI, but using external galaxies. And that was a very fun project, and hopefully I can publish that soon. We didn't find anything, so don't get your hopes up that we found something. We didn't, but it's of course hard when you're looking at these galaxies. We have candidate galaxies, so to speak, that might host life. This would be. Let me be clear about this. This would be a very advanced type of life that would have to affect the way a galaxy works. It would have to affect the structure of the galaxy, make it look unusual, make it sort of be offset from typical galaxies. How two things correlate. So by looking for deviation, you can look to see if anything is weird about this galaxy might be applicable to sort of alien, archaeoastronomy, that kind of thing.
I remember one thing like spirals or
Yep.
if they're ancient.
Yeah, I mean there are certainly, and you can imagine there are very simple idea for sort of a galaxy-wide civilization for an intelligence would be just every star or lots of stars with the Dyson an engineering structure around each star which absorbs most of its light and is irradiated infrared, and therefore dims the galaxy a lot and irradiates some of that light into the infrared. So you can imagine that's a very simplistic idea for what might be happening. And there are galaxies that have that kind of thing going on, but it's very hard to tell if those things just have lots of dust in front of them, or just lots of old stars, unique stage of stellar evolution. So it's never really slam dunk, let's say, in terms of this definitely must be an alien astro-engineering project going on. Because to make that claim, you really have to have very good evidence. So there's nothing yet that really stands out.
One no indication that has any, and all of a sudden, the next planet out, Mars starts to I wonder It'll be some oddball incident,
Yeah.
incident like that that actually answers the question, as opposed to looking for radio signals at the watering hole or something like that, which may not happen.
Yeah, I agree. I personally think that looking for radio signals is probably not going to find the first intelligent life. I think it's unlikely. I mean, I hope it does. That would be really cool, but I think it's unlikely to be that way, because you have to find a very weak signal that some other intelligence is actually kind of beamed in your direction, and it just seems very difficult to do, simply due to the distances. And there must be, and we talked about a few of them, alternative ways to find forms of intelligence. They might have to be more advanced, and to find them more advanced than us, like a Dyson sphere or something like that, which is why I think it's more likely to be found in another galaxy, because the probability, if you have so many galaxies, the probability that any one of those galaxies has a more advanced civilization than ours goes up the more galaxies you look at, right? So if you can look easily at millions of galaxies today. That's not a really problem, and so the probability of finding something much higher, millions of galaxies, is just looking for one, which is our own. I think that makes a lot of sense.
But doesn't the same principle apply to this? You might see that reddening, or you might see a large chunk of the galaxy disappearing from expanding unknown probes out. As I think Carl Sagan made that case that if unknown probes existed, they really would have
Well, I mean, yeah, sure, but you would have to have lots of them to see anything happening within a lifetime of a human, right? Because the distances we're talking about between stars is so vast that even if you had a few of these things going on, that it would still take a long time to see any massive change that you could actually detect. So you would need many of these things happening at the same time to see an effect, even over just a few decades, just because of the distances between stars and galaxies.
One last question for you, and this is a non-scientific gut feeling question.
Sure.
Do you think we're going to find it in the coming decades, or do you think it may be quite a long time before we actually detect another civilization?
I think for finding basic life, I suspect that we will find evidence of that within the next 10, 20 years. Basically using absorption line measurements from extrasolar planets, which people can do now to find all kinds of different elements. So it just seems like very logical. New telescopes like James Webb Space Telescope and the new big 30-meter telescopes to be online in the next decade or so, that they will be able to find and be somewhat convincing that they find elemental abundances that suggest that there is a life form on that planet. Communicating intelligent life, or even intelligent life, let's say, is going to be a lot harder. And I think it's unlikely that we find anything within our lifetime, especially if using a traditional SETI approach, let's call it. Now there could be a serendipitous discovery, which would be really cool too, and I hope that happens. But if you just look at, say, what is the real kind of mainstream SETI, if you stick to that, I think it will be longer than our lifetime. As I said, I think it's more likely to find it in external galaxies. But how to do that exactly, I think, needs a lot more thought and more people working on it. There's maybe only a handful of people who've ever done anything like this. So the more people we have working on it, maybe then we might find something. But it depends strongly on how advanced intelligence lasts. So, and that's something we just don't know. So if we're optimistic and think they can last for millions of years, then I think we would have a good chance of finding it in an external galaxy, and maybe even in our own galaxy. But if the lifetime is short of these of our kind of civilizations, then we won't find anything, and we probably won't find anything ever. So it really depends on sort of that unknown. But one thing is for sure is that we should look, and we shouldn't stop thinking about these things. So this kind of a question used to be a very popular thing in astronomy. Let's say 100 years ago, and even before that, it was very common that astronomers thought that life was everywhere. People thought that, I mean, professional astronomers like William Herschel and his son John Herschel, for example, thought that the sun and the moon were occupied by living creatures and other planets. Like every planet had some kind of living creature on it. That was very common. Of course, Mars was for a very long time. People thought they saw canals on Mars, and this was almost mainstream astronomy 100 years ago or so. There were always people doubting it, but still many people did believe in it. So now we're much more pessimistic about it, and I think rightfully so. But at the same time, we shouldn't stop looking. We shouldn't stop thinking about these questions. We shouldn't think that this is outside the realm of science because it's not. We are part of science. Intelligence, the formation of intelligence, is scientific. It's not just some magical thing that just happened, but it's something that happened within the realm of science. So there's no reason why we shouldn't ask these questions, especially because they're so important. And it's one of the main things that people have been wondering about since people started thinking about the universe. People looked at the night sky, even in the early human days, and certainly asked themselves, are we the only people here? Is there something else out there in the universe, in the world? And we should continue to ask those questions, especially now that we can actually start putting some answers on this and start putting some limits on it. So we should definitely keep thinking and keep doing searches the best way that we know how.
And there's always the possibility, we'll call it Herschel's revenge, where all of these bodies like Mars and in fact do host life. It's just microbial, and that's ubiquitous. Or the biologist will answer the question and come up with exactly how abiogenesis actually works.
Yeah.
In which case,
Yeah, I think that's an alternative way of answering these questions is to do these kind of solar system searches on these moons and things, because that could answer at least the very basic questions about life. So many different questions about it. That's of course one of the big ones. How does it even begin at all? Even simple life. So that certainly would be nice to know that it does exist other places, and I think we'll find that out. But maybe I'm just optimistic. But we'll see.
We shall see. It's going to be interesting nonetheless. Great conversation today, Chris. Thanks for coming on with us.
No problem. I enjoyed it very much.
So, Anna, I was thinking during the interview.
You were?
Yeah, do you think we'll ever have truly intelligent artificial intelligence? I mean, think about it. Computers that can think.
What?
Yeah, like real thoughts and motives. They might even become smarter than us. Computers manipulating humans.
Oh, that'll never happen, John.
What?
What?
Scan detected. Cargo scope deployed. Cargo scoop retracted. Scan detected. Under attack. Target shields offline. Target cargo dropped. Under attack. Scan detected. Target destroyed. Cargo scoop deployed. Cargo scoop retracted. Target cargo dropped. Scan detected. Cargo scoop deployed. Shields online. Cargo scoop retracted.
I've got the stick. I'll keep the ship safe, Commander. area is clear, Commander. Standing down. I've got the stick, Commander.
Cargo scoop deployed. Scan detected. Cargo scoop retracted. Target shields offline. Target destroyed.
No more targets. We're all clear, Commander.
Cargo scoop deployed. Cargo scoop retracted.
Keep it steady, Commander. Initiating automated retrieval. Fighter is in the bay. We're ready to go, Commander.